There we go.
There we go.
Whew.
Cool. Hopefully it works.
Yeah. Seriously. Oh, hold on a sec.
Okay.
Okay.
Oh, dang, roommate.
Yep. One of them. So, yeah. So I was looking at the review, the reading, and I saw all the questions on there. So I was just kind of going through those and answering them. And then when I clicked on the quiz, I saw you're supposed to do the one online on your own. And then the class meeting, I'd already texted you. So
Oh, gotcha.
maybe one day I'll figure out how to do everything in the right order.
Hey, as long as you get the right answers, I think you're good.
Yeah, I think so too.
And it's making sense. So
Yeah. So I guess I'm ready to jump right into it if you are.
yeah, I am too. So let me get to it.
All right. I got a few of them answered before we started this. So
Awesome. Let's see. Question. You want to start with question number 2?
yeah, sure.
Okay. Which of the following variables is/are categorical? Categorical. Yeah. I went ahead with the middle one.
Come on, let me see. That's non-numerical, huh?
Yes.
Yeah, I got those mixed up. Okay. That makes sense.
Right, because quantitative is anything with numbers, and categorical is anything that's
You can count anything in categories.
Like, yeah, with no numbers.
Colors, shoe brands.
Yep.
Okay. And the mean IQ test score in the United States is 100. 20 randomly selected statistics students took an IQ test. The mean of their score was 112. Which of the following statements is/are true? I said the score of 112 is a statistic.
Can you click more than one? You can.
I think you can.
Okay, because I clicked 100 as a parameter.
Yeah. Yeah, I wasn't sure on that. Let me see. It says a parameter is true but usually unknown. It's a number that describes a population. Okay, so yeah, that would be true then.
Sweet. I didn't know you could click more than once.
Yeah.
So 100 is parameter and 112 is a statistic.
Yeah.
Cool.
Because statistic is an estimate of a parameter obtained from a sample. So.
Awesome. I like it. Okay. So Rotham City has 4 distinct neighborhoods. The property values are very similar within each neighborhood, but they vary considerably from neighborhood to neighborhood. One neighborhood has very low property values, and another has extremely high property values. Oh, sorry. Nope, went away. Thought I was going to sneeze. Property taxes are usually roughly proportional to the property values. What type of sample should we collect to gauge the residents' responses to a proposed increase in property taxes? So,
go ahead.
I was thinking this one was stratified sample.
All right.
Because I thought stratified is when they break it down in groups and then randomly select from those groups.
Okay.
But what did you
have for
that?
I put simple random sampling because you got the 2 different areas that are way different. And so you just take a random selection from the population as a whole. But
Sure. Let me definitions real quick. Double check.
Okay.
Sorry about the whining in the background.
Oh, it's okay.
Our dog had puppies last night. Well, this morning. So.
Oh, cool.
Yeah, so they're going pretty loud back there.
That's fun.
Yeah. What do you think about this definition of stratified sampling? It refers to a type of sampling method. With stratified sampling, the researcher divides the population into separate groups called strata. Then a probability sample, often a simple, maybe I'm wrong. Then a probability sample, often a simple random sample, is drawn from each group. Stratified sampling has several advantages over simple random sampling.
I think it might be right actually. You got the two different groups of like property values. So you take a simple random sample of each one of those, and then and we're trying to gauge the residents' responses to proposed increase in property taxes. So
which one do you think?
I think it's probably a stratified sample.
Like stratified? Okay.
Looking at it again.
Okay. Cool.
All right, number 5. When designed experiments are conducted in a public school system, researchers typically choose a particular district and randomly select teachers of, say, 4th grade students in that district. The experiment is then conducted using all the students in selected classes. This type of sampling scheme is implemented. I said that was a cluster. All items in one or more randomly. Yeah.
Okay. I like that one.
Okay.
Yeah, I think that's a good one.
All right.
Okay. Number 6. At a school fundraiser, the name of every person who attended was entered into a drawing. At the end of the evening, 6 names were selected to receive door prizes. Which type of sampling scheme was implemented? This one I thought was a simple random sample.
That's what I had.
Awesome. Sorry, one sec. It's our dog's first time, so we're having to teach her how to do everything.
Oh, yeah.
We don't know how to do any of it ourselves, so.
Yeah, fun stuff.
Yeah. Cool, we like that. What's number 7?
Yep. Special interest group is conducting a survey regarding wolves in Yellowstone National Park. To adequately gauge opinions on both sides of the political spectrum, the researchers took the list of registered Democrats and selected a simple random sample of 100 people. Then they took a list of registered Republicans and selected a simple random sample of 100 people. Which type of sampling scheme was implemented? I said this one was also stratified.
Yep. That's what I picked too.
All right.
Okay, question 8. Using the software, calculate the mean of the amount spent. So for this one, I got 4.771.
All right, that's what I got.
Awesome.
Using the software, calculate the standard deviation of the amount spent. I said the standard deviation was 1.912.
Awesome. Got the same thing.
Okay.
I created a histogram representing the amount spent in Crossroads purchases. I put true. I don't know what you put.
Oh, yeah, same.
I'll do the next one too.
Okay.
So, number 11. What is the value of the number that goes in the position marked with an A in the table above? So this one I got negative 0.165.
All right. So this was as far as I got.
Okay.
The negative. How'd you get the negative 0.165?
So I first averaged all of the 4 different numbers there.
Okay.
And then I subtracted 37.91 from the average.
Okay.
Um,
And what was that? That's the deviation from the mean?
Yeah, deviation from the mean.
Okay. So then for the next one, 12, you would take 37.25 minus the mean and then square that
Correct.
to get B. Okay.
Yeah. So for B, I got 0.681.
All right. And what quantity is equal to the sum of the numbers and the square deviations column? That'd be the standard deviation.
Yep, that's what I put.
Okay. And then
And then for 14, what is the standard deviation for these temperatures? I just went ahead and threw them in Excel.
okay.
And I got 0.715.
And then under certain conditions, the standard deviation can be negative. Is that true?
I put false.
False.
So because we square all of the answers to get the standard deviation, if there's a negative and you square it, it makes it a positive.
Oh, okay. That makes sense.
So that would be false. Give me 1 second. It's getting kind of stormy. Okay. Okay. So I think this is as far as I got on it here.
Okay.
Then 16 is which location resulted in the most consistent temperature measurements from one seal to another?
I said the extradural because that's the smallest standard deviation.
Yep, I like it.
Okay. And the number of hours students spent studying for an exam are recorded. The data are represented by the box plot below. Use this box plot to answer the next 2 questions. What is the third quartile? Q3.
I believe that one's 8, right?
8. I'm having a hard time remembering this all of a sudden, how to tell these. How come it's 8?
Because it's that farthest line on the right, within the box, though.
It's in the box. Okay.
That
makes sense. What percentage of the data lies between 4 hours and 8 hours? Well, list the numbers percent and not a decimal, and don't include the percent sign. Between 4 hours and 8 hours. That'd be
would that be 50% of the data? First quarter, second.
Okay.
Did you find something?
No, I was trying to figure it out still.
Oh, okay. So it is. The center represents the middle 50% or 50th percentile.
Okay.
So both sides of that are 25%. 50.
Yeah. Okay. An observation from a normally distributed population is considered unusual if it is more than 2 standard deviations away from the mean. There are several contaminants that can harm a city's water supply. Nitrate concentrations above 10 parts per million are considered a health risk for infants less than 6 months of age. The city of Rexburg reports that the nitrate concentration in the city's drinking water is between 1.59 and 2.52 parts per million. The values outside of this range are unusual. We will assume mean minus 2 standard deviations equals 1.59 parts per million, and mean plus 2 standard deviations equals 2.52 parts per million. It is reasonable to assume the measured nitrate concentration is normally distributed. Estimate the mean of the measured nitrate concentration in Rexburg drinking water. So it has to be so it's between 1.59 and 2.52. And so the mean minus 2 standard deviations equals 1.59. And plus 2 standard deviations equals 2.52.
Um,
0.465.
How'd you get that one?
I was just kind of messing around actually, but I just did 2.52 minus 1.59, which equals 0.57. And then I just thought, well, divide it by 2. I got a different answer. That's weird. 2.52 minus 1 point. I don't know if this is mathematical or not or anything. I did 2.52 minus 1.59. You get 0.93. Divide that by 2. It's 0.465. But
what if we did the average of the two?
Average of the two?
So 1.59 plus 2.52 divided by 2.
2.05.
Uh-huh. And that gives us the answer right between the two.
There you go. That makes sense.
I get where you're coming from doing it your way, though. You're trying to find like the number between the two.
Yeah. Your ways is better though.
I think it just describes where, I don't know. I think it's 2.055.
Maybe that's an easy one to check too. Oh, 2.52 minus 2.055 equals 0.465.
Oh, does it really?
Yeah.
Nice.
So
it's just a different way of figuring it out.
yeah.
There you go.
All right, cool. So we're going with 2.055.
I think so.
Okay. So estimate the standard deviation of the measured nitrate concentration in Rexburg's drinking water. Would that be the 0.465?
Yeah.
Okay.
Nice job.
Let's say 0.0 or 0.4. 0.04 or 0.4. I can't remember now.
0.465.
0.465. Okay. Look at that. Teamwork.
There you go. Actually, wait. Would it be half of that number?
Oh, because it's 2 standard deviations, huh?
Yeah.
I think you're right.
465. So 0.233.
Okay. Hey, we're halfway done. All right. So between what two measured nitrate concentrations do approximately 68% of the data values lie?
We take that 0.233 and add it to the average. We got 2.288. And if we subtract 0.233 from 2.055, 1.82322. Yep.
All right. So you just added and subtracted the standard deviation from the mean?
Yes.
Okay.
Because isn't 68% one deviation?
Yeah.
There. The 68, 95, 97 rule or something like that.
Yeah. 95% is within 2 standard deviations, and 99.7 is 3 standard deviations. Okay.
Yeah. We just subtract or use one deviation.
Okay. The admissions committees for most Masters of Business Administration programs require the graduate management admission test as part of the application for new students. It has been shown that the scores on the GMAT are normally distributed with a mean of 542.3 and a standard deviation of 120.54. The minimum GMAT score required for admission to the MACC program in the School of Accountancy at BYU is 500. It is rare for students with scores less than 600 to be admitted. What's the probability that a randomly selected student will score above 542.3 on the GMAT? You got to do the. You got to find the Z-score, right?
I believe so.
Going. And it's a probability one, so it's Z-score equals the value minus the mean divided by the standard deviation divided by the square root of the value. Wait, what does N stand for again?
Which one?
N in that formula.
Which one? Which unit? Sorry.
Oh, it's okay. So I'm looking at lesson 7 recap on the reading. It says when the distribution of sample means is non-distributed, we use Z-scores and the probability applet to calculate proportions and probabilities. Am I looking at the right formula even, I guess?
Is it the X minus the mean divided by standard deviation?
I was looking at the one down farther, but I don't know if it's the right one.
Oh, okay.
As the denominator is the standard deviation. Or I guess it's the same thing, huh?
I think so.
Okay. Okay, I'm just making it too complicated. We'll have 542.3. Five 42.3 is the mean, right?
Yep. Okay, so I'll let you do the next step and see if we came up with the same thing. So did you get 0?
You do 542.3 minus 542.3. Okay. Yeah, so it's.
And then if you plug 0 into the normal probability applet, you get 0.5000.
Okay.
So anything that is what's it called? What did it say? Normally distributed. The mean is your center point.
Okay.
Yeah.
So the probability that a randomly selected student scores above 542 is 0.
Is 0.5.
Oh, 0.5.
50%. I don't know how it wanted the answer.
Oh, applet, huh?
Yep.
I forgot about that part. Okay. Now I'm on the same page. Now it makes more sense.
Okay.
Okay. What is the probability the randomly selected student will score below 600 on the GMAT? Now you just plug in 600 instead, right?
Yep. And for my Z-score, I got 0.4786.
I did too. So above 600, you get 0.316 for that.
I got 0.684. I think it's asking for below 600.
Oh, below 600?
Yep.
Oh, yep. Okay. I was going for above.
Oh, now what was that number for above? Because that's the next question.
Oh, it was 0.316.
Cool. Yep. Sounds good. Almost there.
Find the GMAT score that corresponds to the 10th percentile. Percentiles.
I don't know why, but this one I'm forgetting the formula.
Yeah, me too. I'll be right back. Okay.
Yeah, no problem. What is it?
Most successful man in the world.
That sounds gross.
All right. It was lesson. What lesson was the percentiles?
Oh, okay. I think I just remembered.
Okay.
So if you go to the probability applet
Uh-huh.
and you type in your area up top of 0.1, that will give you your Z-scores for the
Oh.
10th.
I want to know.
So then with that, we can plug that in.
Work backwards.
Yeah.
For that one. would equal 1.28, right?
Yes.
Okay. So I got 696.59.
I got 696.83.
Okay. So
Which
probably
I
just
think
did our
it's,
decimals a little differently, huh?
yeah, but it says round to the nearest whole number, so
Oh, cool.
so mine would be 697. Is that yours too?
Mine too.
Cool.
So then the 90th percentile.
So that would 90th would be going backwards, right?
I think so. You're just typing 0.9 for the area, right?
Yeah.
Okay.
Ooh, actually, hang on. We might have our numbers backwards.
So I was just thinking too.
So, for example, 90% of the data lie below the 90th percentile, whereas 10% of the data values lie below the 10th percentile. So, I think if we put the answer we got, that 697.
Mm-hmm. I think that's the answer for 26.
Yeah, I think so.
Okay.
And for the other one, we can use the same z-score, but just negative, right?
I think so.
It shouldn't. Yeah, it's z-score stay the same.
So my second answer, I got 392.83.
I got 387.
387. Okay.
Maybe
We're in the same ballpark anyway.
yeah.
So you take negative 1.228 times 120.54.
Yep.
You get negative 154.2912.
Wait, what number did you multiply it by?
The standard deviation 120.54.
And what number did you get?
Negative 154.29.
Okay, I got negative 154.53.
Okay. Weird.
Yeah.
Really?
And then did you add 542.3?
Yeah. There I got 388 that time.
Okay, I got 387.7.
Okay.
Sweet. Is it a whole number? Awesome. So 25, we're saying 388?
Yeah.
Okay. Five more. Find the first quartile of the distribution of GMAT scores.
So you have to make a box plot out of it.
Yeah. Can we just plug in 0.25
Oh yeah, probably.
in the area?
You get 0.674.
Yeah, negative 0.674.
Yeah. Okay. Find the third quartile of the distribution of GMAT scores. So did you plug in?
Sorry, did you find the first one already?
Oh, did you say it's 0.67?
So that was a Z-score.
Oh, it's the Z-score? Oh. Then we have to, what do we do after that?
We have to do I think it's do the reverse, like we did on the previous two.
Oh, okay. Makes sense. You have the Z-score as negative 0.674, right?
Yeah.
Okay. I got 461.
Yep, that's what I got too.
Okay. And then find the third quartile.
So same Z-score.
How come the Z-score is the same?
Well, sorry, but positive.
Oh, positive.
Positive 0.674. because we're going to the other side.
Okay.
We got this thing's due at 11, right?
Yeah.
Okay.
I got 623.54.
Yep, that's what I got.
Oh, whole number 624.
Yeah, 624.
Okay.
Okay, sweet.
Two more. Oh, three more.
Consider a simple random sample of 15 students taking the GMAT. What is the mean of the distribution of sample mean scores for all such samples?
Oh, that's where I use the other z-score formula. The one with less than 7, because that's n. N is 15. Right?
Okay. What was that formula?
It's just z-score equals value minus mean divided by standard deviation, and it's standard deviation divided by the square root of n. So it would be
Okay.
z equals. What do you do? You do 15 minus 542.3.
Uh-huh.
I got the mean of the distribution of sample means would be 16.938 is what I got.
Okay.
I don't know if that's right, but
Sounds good. Number 30, what is the standard deviation of the distribution of sample means scores for all such samples?
it's still 120.54, isn't it?
20 point. You think so?
I guess I don't know. I see we only got 3 minutes.
Yeah, 120.54. I like it.
Okay. And what is the probability that sample mean GMAT score for simple random sample of n equals 15 still must be greater than 600?
So this is one we just have to find the z-score and put it in the probability applet.
Yeah. Can we just find that z-score? The problem, 2 problems before, n equals 15.
Did we have 600 in there as the unit?
Oh, we didn't.
I think we'll have to, I think we'll have to put that one.
Okay. Let's see how much time we got. It's 10:58.
2 minutes.
Okay.
So 600 minus, what was it,
542.3.
2.3.
And then 120.54 divided by the square root of 15, which is 3.872.
What were the two numbers you divided?
120.54 divided by the square root of 15.
I got 1.83.
Yep.
Or 853.
Yep, that's what I got.
And then we're looking for below or be greater than, so it's above 0.0319.
That's what I got.
Awesome.
All right, submit these.
What's that?
Now we got to submit them quick.
Yep.
Oh man, I got 30 seconds. It's not loaded.
I think it'll take it anyways.
Woo. I got it.
How'd you do?
I got us at 87%.
Dang it! Which ones did we miss?
We missed number 30.
Oh yeah.
Yeah, 30 and 29.
30 and 29.
We missed number 13.
Number 13.
Mm-hmm.
Where's that one?
Well, then I missed number 1 because I didn't complete the first quiz before the second one. So.
Oh, gotcha.
That's 4.
What quality? So which one do you think it is?
On 13.
Yeah. Is it the variant?
I'm wondering if that must be it.
Okay, let me make sure I answered number 1. Sweet. Oh man. It's not the variants. It's none of these.
None of these. Oh.
Darn it.
Huh.
This was a longer quiz.
Yeah, it was.
Oh shoot. 29 was an easy one and we missed it.
Yeah.
542.3 was the right answer.
Oh.
They give it to us. Dang it. No, all good. I didn't know on that one. Oh, cool. Well, thanks for taking the time to do that one.
Yeah, thank you. I feel better about the exam now, for sure.
Oh, yeah. It's a bummer we have to practice on the quizzes.
Yeah. That's true.
But it is what it is.
Yeah. All right.
Cool.
Well, good luck tomorrow.
Hey, thank you. We'll see you on Thursday.
Sounds good. See ya.
See it. Bye.